Dear student, in this video, I am going to share with you the stereochemistry of perhydrophenanthrene. This is the structure of perhydrophenanthrene. So this ring is denoted as A, this one is B, and this is the C. The numbering in this system is given from this carbon 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, and the fused carbons are numbered at the end 11, 12, 13, 14. The star indicate that number 13, 14, and 12, 11 carbon, they are the asymmetric carbons or the chiral carbons. So there are total 4 asymmetric centers: C11, C12, C13, and C14. The expected stereoisomers are 2 raised to 4. That is the formula generally we use. 2 raised to n. N stands for number of number of asymmetric centers. So 2 raised to 4 is equal to 60. But the observed isomer in this case are less than the expected number, that is 16. So the number of stereoisomers are less. Now here some terms we generally use. The first term with respect to ring A and B and C. So with respect to ring A and B, as ring A is the 6-membered ring, B is also 6-membered ring, then AB fused with either cis fusion or trans fusion. So AB fusion, 6-6 fusion, it can be either 6, that is cis fusion, or it can be a trans fusion. So BC, again the same, either it can be cis or trans. So the adjacent rings which are fused at the carbon number 13 and 14 and at carbon number 12 and 11, they are either at cis fused or trans fused. The another number that we have to consider, that is ring A and C. Look at ring A and C. They are the terminal ring, and there that 12-13 bond is common in between these two. That is 12-13 bond is attached with each other by the 1-2 relation. So this we call it is a AC, that is the relation with the terminal ring. That relation is a 1-2 relation. So from here 1-2 relation, if I go from this way, then it is a 1-4 relation. But now in this stereochemistry, we had to always focus on number 12 and number 13, how they are related. What is the relation at these 2 points? Whether the relation is syn relation or anti-relation. The syn relation means the terminal rings have the same stereochemistry at 13 and 12 number carbon atoms, while the anti-relation is the stereochemistry at C13 and C12 is different. So that the terms generally we use: AB fusion, either can be cis-trans, BC fusion, it can be cis-trans, but the terminal ring relation, either it is syn or anti. The one more thing that we have to always remember in this case, at the fused center, if the hydrogen is alpha, that is facing in downward direction, these are the 4 fused carbon. At the fused carbon, if the hydrogen is facing in the downward direction, then it is not denoted by the dot. And if it is facing in the upward direction, then we have to place a dot at that fused carbon. So these are the different terms that we have to use in perhydrophenanthrene structure. And this is an example of 6-6-6 fusion. So how to name the system? So while we are going to name the system, first of all, we have to name how the ring AB is fused, then ring AC relation, and then BC fusion. So the first molecule is trans-anti-trans. Here the AB relation is, you can see this is there is a presence of a dot here and no dot. Dot means the hydrogen is beta here, that is facing in upper direction. No dot means it is going in a downward direction, or in other words, simple, that the stereochemistry at these two fusion point is opposite, so it is named as a trans. The relation between the terminal rings, now A and C, this is up hydrogen, this one is down. So relation is opposite, so it is termed as anti. And BC fusion, again, down hydrogen, up hydrogen, the relation is opposite, so it is a trans. So AB fusion trans, AC relation is anti, and BC fusion is again a trans. This exists in a plus minus DL pair. So this is the first stereoisomer named as trans anti-trans. The second stereoisomer is cis anti-trans. So this is the structure for cis anti-trans. EB fusion is cis. So you can see the stereochemistry at fuse point is both the hydrogens are facing in the same direction. The AC relation is opposite, one up, one down. The trans BC relation is trans, down, up. So the stereochemistry is different. Again, this stereoisomer exists in a DL pair. The third one is cis-syn trans. Now in cis-syn trans, the AB relation is, AB fusion is, the stereochemistry is same at the fuse center, therefore it is cis. The stereochemistry at the terminal ring, the relation here is again the same relation, that is syn relation. And the BC fusion is a dot here and no dot here. So it is a trans one. Again, this one also exists in our DL pair. The fourth is cis anti-cis. Now, here the cis AB fusion, so dot, dot, same stereochemistry. So it is cis. Relation with respect to terminal ring, dot, no dot, therefore it is anti. As it is no dot here, and the relation that is a fusion is cis, so no dot, there should not a dot over here. So again, no dot means stereochemistry is same, therefore BC fusion is cis. And this exists in a TL pair, that means it is optically active. The next stereoisomer is syn cis cis. This is the structure of syn cis syn cis. Here, the stereochemistry at each and every fused carbon is that all the hydrogens are facing in top direction. Therefore, AB fusion is syn, AC relation is, AB relation is cis, AC relation is syn, and again BC relation is cis, and this compound is meso, that is optically inactive. Now, the last stereoisomer is trans-syn trans. So, the structure for this molecule is AB fusion is trans. Look at the fusion center. This hydrogen is up, this hydrogen down, so trans. The stereochemistry at this 2 point, it is same, so it is syn, and again BC fusion is trans. So up and down, so different stereochemistry. So again, this compound is meso. So overall, the expected stereoisomers are 16, but how? This is 2, 2, 2, and this 2, that is total 8 stereoisomers, and this one is 9 and 10. So instead of 16 stereoisomers, here we will get only the 10 stereoisomers. So total stereoisomers are 10 instead of 16. Now how to draw the stereo structures? So drawing of stereo structures, some few things we have to remember. AB fusion is a cis-cis fusion, 6-6 fusion. It is 1-2 fuse systems, which can be either cis or trans, that is 1-2 AE or EA or EE. So we have these different types of bonding can be possible in 1-2 fuse system. Among that, AE and EA is a cis fusion, while EE is a trans fusion. Again, the BC fusion is 6-6 fusion, and again it is a 1-2 fuse system, which can be a cis or trans. So same the fusion possibilities 1-2 AE, EA, and EE. The AC relation is again a 1-2. It can be syn or anti. So 1-2 cis energy, if the fusion 1-2, that is a AB fusion, if it is a cis, then the energy is 2.4 kilocalorie per mole. If the 1-2 fusion is trans, then energy is 0 kilocalorie per mole. That we already discussed in case of a decalin system. In cis decalin system, that is 6-6 fusion, the energy for this is 2.4 kilocalorie per mole for cis decalin system, which is observed one. And of course, the calculated one is the 2.7 kilocalorie per mole. While for 1-2 trans energy, trans decalin system, it is 0 because of absence of butane-Gauch interaction. So this is with respect to the 6-6 fusion, AB and BC. The next one is, what are the different relations that we observed with respect to the terminal rings? That is with respect to A ring and C ring. What are the different interactions with respect to terminal ring? So we have a 1-3 relation there. We have a 1-2 relation. So in 1-3 relation, if there is a AE, EA or EE, then 0 energy. If 1-3 AA is there, then you add 1.8 kilocalorie per mole. If it is 1-2 EE, AE or EA, you add 0.9 kilocalorie per mole. 1-2 AA, the energy is 0. So these are the factors that we have to consider when we are going to draw the stereo structure, and after that we have to find out the stereochemistry and the energy of the different stereoisomers. So here, these are the some factors that we have to remember, that which energies we have to consider for the energy calculation. So the same is written here. The perhydrophenanthrene, AB fusion, BC fusion and AC relation. AB fusion is 1-2 fusion, BC fusion is again 1-2 fusion, AC relation is 1-2 relation. 1-2 fusion is cis or trans. Same, this one cis or trans, and here this can be syn or anti. The one more thing I have mentioned over here, that if there is a cis-syn relation, then change the label. So label change means if you start with equatorial bond, the next bond that we have to use axial. So that is the label change. You change the label. But if it is a trans, then don't change the label, trans or anti. So this is applicable only if the relation between the two rings is 1-2. If the cis relation is there, if you start with the labeling equatorial, the next bond that we have to use is axial. If it is in cis-syn relation, if I have a equatorial bond, the next one is axial. So that we will discuss in detail in the next slide. So this is the first structure, trans-anti-trans perhydrophenanthrene. So this is ring A, B, C. Now I have given a number to the central ring only, because from after when we are going to draw the stereo structure of this compound, so we need a central ring. That's why I mentioned here only the number to the central ring system. So the numbering, in what way you have to give, that I have already explained in the first slide. Now, after this, whatever, now this EE, they are the label. Now, how we have to go with this? So, if number 14, if we are using an equatorial bond for the ring formation, so that means it is E. And as it is AB fusion, it's trans. So AB fusion trans means if you are going with the next carbon, don't change the label. If it is a trans, don't change the label. So if I start with equatorial, then here has to be again an equatorial. So what we discussed in previous slide, don't change the label when it is a trans relation. Now look at A and C relation. If it is a equatorial here, then it is an anti relation, 1 to anti, again no change. So here it is equatorial, therefore this one is also again a equatorial. Now look at here that BC relation, the dot, no dot here means again it is a trans relation. Trans means no change in the label. So equatorial, it remains equatorial. So these are the simple way of giving a label. The another one is what? Another possibility. Instead of start with equatorial, I can also start with axial and see what it gives. Instead of equatorial, if I start with axial, it is a trans, no change. Again, it is axial. It is anti, again, no change. Again, it is axial. This one is trans, so no change. Again, axial. So all the bonds are axial, and you know that the axial bond, and again it is a 1,2 fusion. 1,2 fusion axial is disallowed, that we already discussed in trans-decalene, why this not undergo flipping. So 1,2 AA fusion is disallowed, and as the 1,2 AA fusion is not possible. Now this is the structure of this ring. So this is the stereo structure of this ring. The central ring B, 14 number equatorial bond, 13 number equatorial bond, 13 number hydrogen is up, so hydrogen is up, 14 number hydrogen is down, so it is down hydrogen. The number 12, it is again the hydrogen going in a downward direction. Number 11, hydrogen going in up direction. So you can see this is the stereo structure of the trans-anti-trans perhydrophenanthrene. Let us see how to draw the stereo structure. So first, what you have to take care, first you draw the ring B in chair conformer. So first your duty is to draw the ring, the central ring in chair conformer. After drawing the ring B in chair conformer, the next, the ring A is on the left side of B. So what is the stereochemistry that is mentioned at the fused carbon? That is one hydrogen up and one hydrogen down. So one hydrogen up and one hydrogen down, and the ring bond that we have to use, they are the equatorial. So what we have to write down first of all, now we don't know which one is 13 and 14. The only thing is what we have to do, the hydrogens that we have to, that they have mentioned, the one up and one down. So that hydrogens, first of all, you mentioned here that one hydrogen up and one hydrogen down. Then you may have a question. The another possibility can be one hydrogen down in an equatorial way and one hydrogen up in a again an equatorial way. So both the equatorial hydrogen can be possible, but equatorial bonds we require for the ring formation. So that we already mentioned here, equatorial bonds are required for formation of ring A. That's why the hydrogen has to be axial. So one hydrogen axial, which is top, and one hydrogen axial, which is down. So this is the first thing. The second thing is what? After putting the hydrogen, next, whatever the equatorial bonds are remain, that equatorial bonds we had to draw. And after drawing the equatorial bond, then the next your duty is to complete the ring. So 1, 2, 3. So these 3 bonds that you have already drawn, now the question arises, which one is number 13 carbon and which one number 14 carbon? So which is the 13 carbon? 13 carbon is that carbon where you have a beta hydrogen and the bond equatorial bond. So beta hydrogen is present here and the bond equatorial present here. So this carbon is number 13 carbon. So once you give that carbon as a 13 number carbon, automatically this carbon is number 14. Once you get this number 14, So 14, when you complete the remaining numbering 9, 10, 11, 12, and at the same time, you complete this ring also. So this ring, when you are going to complete this ring A, the another bond that you have to draw a parallel with this equatorial bond. So this bond, in that way, you have to draw a parallel with respect to the neighboring equatorial bond. So this is number 14 carbon. After giving the number 14, the next you complete the ring. So complete the ring that just now I explained you, this bond has to be parallel with this equatorial bond. So automatically the remaining thing that you have to complete. So this is going in the downward direction. The reason is these three bonds are in top direction. So the next numbering that we have to complete 9, 10, 11 and 12. Next duty is to go for the next ring C. So ring C start from 10, 12 and 11. So you focus on 12 and 11. So after focusing on 12 and 11, look at the stereochemistry of hydrogen at 12 and hydrogen at 11. So 12 hydrogen going in a downward direction. So 12 hydrogen downward direction, 11 hydrogen going in the up direction, and the remaining ring bonds are, both bonds are equatorial. So number 12 equatorial bond, number 11 equatorial bond. So that is the next step to draw the equatorial bond. Once you complete this, now when you are going to draw, when you are going to complete the ring C, this bond has to be parallel with this neighboring equatorial bond. So you complete the next ring. So in that way, the ring is completed, and that is ring C. So this is ring C. So overall, in that way, we have to draw the 666 fusion, and the name of this isomer is trans-anti-trans perhydrophenanthrene. Now, the energy calculation. How to calculate the energy of this molecule? So, what are the things? AB fusion is cis? No, it is a transfusion. So, transfusion means energy is 0. BC fusion is again a trans, so energy is 0. Right? So how to calculate the energy of this molecule? So you can see here, AB is 1,2 transfusion, therefore 0 kilocalorie per mole. BC, again it is 1,2 transfusion, therefore again energy is 0 kilocalorie per mole. Now the next energy that we have to calculate with respect to the terminal ring. With respect to terminal ring, which are the relations you have? This is 1 and 2 relation. So number 13 and number 12, there is a 1-2 relation, and one more, that is number 14 and number 12, that is the 1-3 relation, and the another is, again you can see the another 1-3 relation is, that is number 13 and number 11. So these are the three relations that you have, that is first relation 1-2, the second relation this 1-2-3, and the next relation this 1-2-3. So these are the relations we have. But in this relation, look at the 1-2 equatorial bond, they are causing the interaction. So as 1-2-EE, that for that we have to add one butane-Gauge interaction, and one butane-Gauge interaction is 0.9 kilocalorie per mole. But if I go with the 1-3 relation, so number 14, you focus on number 14 and number 12, both the bonds are equatorial. And 1-3 equatorial interaction is 0. Same, this numbers 11 and number 13, again these bonds are equatorial, they never interact. So 1-3 EE interaction is 0. 1-3 EE, this one interaction is 0. So overall, the total energy of this molecule is 0.9 kilocalorie per mole, and that 0.9 is because of C13 equatorial bond and C12 equatorial bond. Now the optical activity of trans-anti-trans perhydrophenanthrene. So this is the stereo structure that we already shown how to draw the stereo structure. Now the question arises how to draw the mirror image of this. If I want to talk about the optical activity, then we have to draw the mirror image of this structure. So how to show the mirror image of this structure? So first your duty is to show the flip structure of central ring B. So you can see here, this is the ring B. What you have to do? You flip the ring B, the number 11 in the downward direction, number 14 in top direction. But the numbering, remember, we are not flipping it, so it should not be, once it go down, if it go down, it should not be a number 11 carbon, as we are drawing the mirror image. So this carbon has to be 14. Okay. So next one is what? After flipping of ring B, next your job is to give the number. So number is what? Number is here for 14. 14 is attached to 9. 9 attached to 10, 11, 12, 13. So just you are drawing the exact mirror image of B. So you can see this is the mirror image of B. Right? So this is nothing but the number that you have to mention by looking at this stereo structure. First of all, this number, that is 11, 10, 9, 14, 13, 12. After this giving a number, next your duty is to whatever the substituents are there, that is a hydrogens, on which position the hydrogens are there. So all the hydrogens are axial. Remember, we are not flipping the ring, so the axial remains axial. So look at the number 11, there is a presence of axial hydrogen. Number 13, again axial hydrogen. Number 12, axial hydrogen but going in a downward direction. Number 14, again axial hydrogen going in the downward direction. So this is the next step. The next thing is what? Whatever the remaining bonds are there, that bonds you have to draw. Once you complete the hydrogen, the remaining bond is equatorial. The hydrogen, the remaining bond is equatorial. In the same way, the remaining bonds are equatorial. Once you complete it, then your duty is to complete the ring also. So how to complete this ring A? That here you have to draw this way, that is parallel with this line. So this one, and then you complete the ring. Same here, that here you have to draw the parallel line with the neighboring equatorial bond. So this has to be like this. So it has to be like this, and then you complete the ring. So next structure is this way, you complete the structure. So this is the mirror image of this structure. You can see everywhere that 10 is near to that. Then this pointed part is this one. So everywhere there is a reflection, and you can see here that this molecule and the mirror image of this one. So exact a mirror image, and this mirror image is optically that there are presence of four chiral center, no symmetry, and resolution can be possible. So it exists in a DL pair. So this compound is optically active. So for this, you refer the different books that I have mentioned here.